in as general and simple terms as possible, a very broad overview of what you work on.
I tried to explain the difference between theorems and theories. A theorem is proved in the context of a theory. And I think I'm inclined to theories. An example of someone who is inclined to theorem is your colleague, Andrew Wiles.
Mm-hmm.
He proved a theorem.
Yes.
He proved a theorem, but he proved the theorem in the context of modern number theory, not in the context of Fermat, but it's the same thing.
Yeah.
And nonetheless, Wiles approached it in the context of a very large theory. So my impulse is to I'm more attracted by willy-nilly, not by any reflective choice, but just by the drift, just by my impulses, just by the movement of my impulses, to look for a theory. That usually has to intimate at least one success, because you can never, not never, but it takes a very long time to create a theory.
Yeah.
It's not the task of an individual usually. Think of the difference between an architect and a craftsman. In the context of the past, the history of construction, there have been these two people, and they played quite different roles, quite essential. So the architect was not responsible for the decoration in the church or the statues of the saints, but he was responsible for something, which was beyond simply creating a structure which would stand. He had to create something which would stand, and on which the other properties could be imposed. Then we give you studied mathematics of it. Now, we learn about numbers as we go along. We learn about a very early age. We ate 1, 2, 3, 4, 5, and then 1/2, 5, 6, and so on. But then you go on, and you somehow or other you begin to accept the notion of a real number, what a mathematician calls a real number, and you don't know whether it's the same or different than the numbers you have, right? You don't know whether pi is a hard thing to define. Now, so you have pi, and then you have 2 pi i. 2 pi i. Now, if you're like me, it never occurred to you why we stopped there. In other words, we have a real number A, and a real number B, and A plus BI. Why did we stop there? In other words, you took it for granted that we should stop there. I mean, there's no reason when you start to work with numbers to think, well, we have A plus BI, and then if we calculate an integral, we're going to have some other kind of number, and if we're going to have an equation with then we can start to think of a polynomial or something with complex coefficients. Then we look at the zeros, or even some more complicated function like cosine and so on. And we're going to look at it zeros, and we should go up and up and up and up. We don't. It was very, very late in my life when I recognized that this was a fact that governs the life of a mathematician, and that I, at least, was an ancient man when it occurred to me that this might have been otherwise. So you have a theory of complex numbers. So there's a theory which is relatively simple, and you have it. Boom.